Now, the mistake that I started to make was putting these together, but you can't. You have to take out the I separately. And then that becomes I squared times the square root of 8 times 32. Okay? If you want to do your factor tree on that, 32 is the same as what? 8 times 4. And 4 is the same as 2 times 2. So I've got a lot of things that it looks like whatever the result is of 8 times 32, that's probably a perfect square. Probably 16 squared. Eight times 2 times 2. Which is 8 squared times 2 squared, which is 16 squared. So this becomes, the I squared becomes a negative 1. 16 squared under the radical becomes a 16. So then this becomes negative 16. Okay, so number 4, when you're multiplying all of those together, look at your coefficients. You've got 3 and 4 and 5. We just multiply negative 3 and negative 5. Just multiply them all together. What do you get? Negative 3 times 4 times negative 5. What is that?
60.
Positive 60. 60 I cubed. I cubed can be written as I squared times I. And that's the process, that's how you need to look at any exponents on I, as how many I squareds is that? Because I squared is negative 1. I squared and negative 1 can be substituted for each other. So that means this is going to be the same as 60 times negative 1 times I. Negative 60 I. Here's what we're going to do with I to the 55th. We're going to make it have, instead of I to the 55th, I want an even exponent. So I'm going to make it I to the 54th times I. I need it to have an even exponent. And here's why. Because if it has an even exponent, I can call that I squared. 2 times what is 54? 54 divided by 2. 27 times I. I squared, negative 1 to the 27th, not negative 27, negative 1 to the 27th times I. What is negative 1 to the 3rd power? Negative 1. Negative 1 to the 4th? Positive 1. Negative 1 to the 5th? Negative 1 to the 6th? Positive. So that's going to follow that pattern all the way up through 27. If there's an odd exponent, then it's going to turn into a negative 1. If it's an even exponent, then it'll be simplified down to a positive 1. So this right here can be replaced with negative 1 to the 1st times I, which is just negative I. Negative 1 to the 44th power times I, and negative 1 to an even exponent is going to be a positive 1. positive 1 times I, yeah. So, moral of the story, I to an odd exponent will be I. That's not true, because that one was an odd exponent. I guess no generalization there. I to the 89th, if you divide it by 2. All right, we'll just go through the whole process. All right, look at number, I did not move. But all you really need to do is, if there's a negative sign, like on 13, if there's a negative sign, you need to distribute that through. So let's do 13 instead. We'll do 13 and, I think it's 14. We'll do 13. So if you distribute the negative sign through, then you get 28 minus 4i minus 10 plus 30i. And then you can look at combining your like terms. That'll be 18. And then a plus 26i. And that's really all you have to do. The book goes through and tries to pair them up in a certain way, and maybe they're trying to set you up for something later. But it follows the same algebra rules if you do it that way. Yes. But over here on 14, it's different because this is multiplication. So you need a FOIL here. This one's a little more complicated. You got to go through the FOIL process. 6 times 6. 6 times 4i. Negative 4i times 6. Negative 4i times positive 4i. So what happens in the middle? Those two cancel out. You're left with 36 minus 16i squared. What do you think I'm going to do next? Substitute the I squared, that's right. Instead of I squared, I'm going to put negative 1. So it'll turn into 36 plus 16, right? Which becomes 52. There's a couple different ways to do this. I think the easiest way would be to subtract 35 from both sides. You get 5n squared equals negative 35. Then, that's right, divide both sides by 5. And then I don't want n squared, I want n to the first, so we got square root of both sides. And when you take the square root, remember you have two answers. You have a positive and a negative answer. The square root of 4 is actually plus or minus 2, not just 2 anymore. Square root of 4 is plus or minus 2. So the square root of n squared is going to be plus or minus square root of negative 7. So n squared will be plus or minus square root of negative 7. Which means, what do I need to do? Pull the I out. Plus or minus I square root of 7. Square root of 7 doesn't have any perfect square factors. It's prime. So then that means that this is where I have to stop with my answer. Let's leave it under the radical. So step 1 would be to subtract your 12. 3/4 x squared, negative 12. And then in a fraction there, multiply both sides by the inverse. Times 4 over 3. Okay? So 4/3 times 3/4 is 1. I get x squared equals, you can reduce now if you want. 12 is the same as 12 over 1. So the 12 and 3 can reduce to 1 and 4. And 4 times 4 is 16. Forget about the negative. Then take the square root of both sides again. X would be plus or minus square root of negative 16. Pull the I out. And the square root of 16 is 4. So it would be I plus or minus I 4i. So if we want to write the equation for this parabola, we can kind of work backwards from finding the roots. Kind of like, solving a quadratic, but working it backwards. So what are the roots of this parabola? Right. So x equals 1 or x equals negative 3. That's negative 3 right there. That's positive 1 right there. That's where it hits the x-axis. And then you can FOIL. I'll go back up to the top here. Get x squared plus 3x. There's x squared, there's the 3x, minus x, minus 3. So then in the middle, that's equal to 0. X squared minus 2x minus 3 equals 0. Oh, plus 2x. Here's what we learned in number 1. What is x going to have to be? If you've already been, they've already factored this quadratic force. They've already broken it down into two binomials. So if x minus 1 times x minus 5 is 0, then x either has to be 1 or 5. If x is 1, you get 0. If x is 1, you get 0 times negative 4, which is 0. If x is 5, you get 5 minus 1 is 4 times 0, which is still 0. So what we did, we said, okay, if x minus 1 times x minus 5 is 0, then either x minus 1 is 0 or x minus 5 is 0. That's the zero product property. Add 1 to both sides, x is 1. Add 5 to both sides here, x is 5. So those are your answers. That's the other way to look at it. An equation that has 2 and 5 as its roots. In other words, that's where the parabola hit the x-axis, which is just like problem number 1. We look for the roots. Where does it hit the x-axis? So we got 5 and 2. We're going to set up as x equals 2 or x equals 5, which means x minus 2 is 0 or x minus 5 is 0, which means, using what we learned in problem 2, x minus 2 times x minus 5 has got to be 0. Which means x squared minus 5x minus 2x plus 10, 0. You combine your middle terms, and you get, you set it equal to 0 or set it equal to y. I guess it's better if it's over there. That would be the equation of a parabola that would have as its roots 2 and 5. Let's skip to number 4. Let's do number 5. If we want to solve this, x squared plus 6x minus 6 equals negative 6. Well, plus 6, we set it equal to 0. That's always the first step. And then if we wanted to try to factor it by hand, well, all right. I need that to be 6. I need that to be x squared. And I need these two to add up to 6x. So x and x. And then I need a number here. I need two numbers here that will, and they're going to have to both be positive. They need to add up together to give me 6 and multiply together to give me 6. Can you think of any? 3 and 2? No, I don't know. 3 and 3? No, that doesn't work. It doesn't work both ways. 6 and 1, 3 and 2, 2 and 3, 3 and 3, 1 and 5, 4. So it's probably going to be a decimal. So if it's a decimal and we don't know the quadratic formula yet, then we're going to use the calculator. So take it, put it into Y1, and go to the table. And you're looking for where it changes from a negative number to a positive number, or a positive number to a negative number. Because in between there is 0. You may not see 0 anywhere on the list, on the Y list. And if you did see 0 there, then we could have factored it. So tell me some of the numbers on the Y list where it changes from negative to positive. So 1, negative 2, and then what's the number below that? 2 what? What? 2, 2?
222.
Whoa.
No, because I was saying.
What is one of the points on the T chart?
Negative 1, 1.
Negative 1, 1. All right, what's another one? 0, 6. Okay, what's 1? Okay, so I'm getting away from it. Let's go the other direction. What is negative 2? Negative 2, negative 2?
Yes.
Okay, what's negative 3?
Negative 3.
What's negative 4? Okay, what's negative 5? Okay, so I see the symmetry, and that means in here and in here was 0. So if the roots cannot be found, state the consecutive integers for which they're between. The root is going to be between negative 1 and negative 2. And the other root is going to be, so that'll be your first root. The second root will be between negative 4 and negative 5. We don't know exactly. We'll do it the same way we did number 5. Except this time we're going to graph the points that I find on the T chart. So put it into Y1. And tell me some numbers from our table off of our calculator that will fit on this graph. 0, 3 is 1. That would be right here, okay? What's another one? 1, 0, that would be right here, okay? 2, negative 1, 2, negative 1 be right there, okay? 3, 0, 4, 3, and 8 goes off the screen. So my parabola looks something like this. So if I want to solve, then these are my solutions. These roots are my solutions. X equals 1 or X equals 3. Those are the solutions. Those will make this equal to 0. All right, number 7. Is that going to be opening up or opening down?
Opening up.
Up. It's going to be pointing down, opening up. Because it has a positive 1/2. So it's going to look something like this. And that means it's going to have which one? A maximum or a minimum? Minimum. At the vertex. What is the coordinate of the vertex? No. Go to your calculator, go to the table, and figure out where it started changing directions at, where it turned around and went the other way. The y values will get smaller, 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 and then they'll start getting bigger, bigger, bigger again. At what point did they decide they didn't want to get any more, they didn't want to get smaller anymore, and they wanted to start getting bigger? Yeah, tell me what? Yeah, but I want to know where the vertex is at. Negative 4, 3, then what happens next?
Negative 5, 8.5.
Okay, what was it, negative 3? Okay, negative 4?
3.
Okay. So we're getting bigger again? Let me see. No, it's getting smaller. Negative 2, negative 5, negative 1, negative 7.5. That's getting smaller. 0, negative 9. And then 1, negative 9.5. And then when I get to 2, it starts getting bigger again. Negative 9. So at this point is where is the middle of that symmetry. That's your vertex. 1, negative 9.5. So your minimum would be at negative 9.5. That's the smallest y value you ever have, negative 9.5. So when we're factoring, the x squared, we'll set it equal to 0. X squared minus 7x minus 18 equals 0. So we want to factor that into two binomials. We're going to go ahead and use the box method. X squared goes there, negative 18 goes there. This has to be an x and an x. For that to be a negative 18, that means one of them's going to have to be negative, one of them's going to have to be positive. So I need two numbers that will multiply together to give me negative 18, but add together to give me negative 7. Okay? So he's saying 9 and 2, with a negative being the 9, and the positive being the 2. So negative 9 times positive 2 is negative 18. That checks out. Negative 9 times x is negative 9x. Positive 2 times x is 2x. Negative 9x plus 2x is negative 7x. So that checks out. So that means that this factored into x minus 9 and x plus 2. So that means that x must have been, can I skip the step? say x must be 9 or x is negative 2. Take them apart, set them equal to 0 each, and then solve for x. So on number 9, we're going to set it equal to 0 again. 4x squared minus x equals 0. Well, you really don't want to divide by x here because you lose one of the factors. So you can factor out an x, and you get 4x minus 1 equals 0. Then you can break it up into 2. X equals 0, or 4x minus 1 is 0. If x is 0, you get 0 times negative 1, which is 0. Or, in this case, what would x have to be to make this part 0? Well, I don't know, add 1. 4x equals 1. Divide by 4. Put 1/4 in. What's a fourth of 4? What's a fourth of 4? Oh, gosh. 1.
1.
Thank you. What's 1 minus 1? 0. And 0 times a fourth is 0.